A team of researchers from Cornell University, led by Associate Professor Khurram Afridi, has pioneered a new wireless charging method for electric vehicles, EVs, inspired partly by his time working at NASA, a Cornell Chronicle post explains. The new approach, which takes cues from NASA's methods for sending data through deep space, could revolutionize EV infrastructures by enabling electric vehicles and autonomous factory machines to charge while driving. The problem with traditional wireless charging concepts. The concept of wireless charging dates back to the 1890s when Nikola Tesla bedazzled audiences by using alternating electric fields to light up unplugged fluorescent lamps. Since then, the concept has shown promise for charging vehicles wirelessly. Sweden is currently working on a localized project, but is yet to take off. The concept that has so far gained the most traction uses alternating magnetic fields generated using existing electric currents along a road. The main problem with this method is that magnetic fields are unwieldy and they must be controlled to stop them from harming passengers or heating up reinforcement bars on the road. Meanwhile, ferrite, the material used to guide fields, is brittle, expensive, and loses a lot of energy when magnetic fields are changing quickly. Inspiration from outer space. Khurram Afridi, Associate Professor of Electrical and Computer Engineering in the College of Engineering at Cornell University, devised a solution to these problems inspired by space communications. Wireless power transfer is based on the same underlying physics used to send messages through radio waves to spacecraft in deep space, things like Voyager, Afridi said. Except now we are sending much more energy across much shorter distances, to moving vehicles. At the end of Afridi's sophomore year at the California Institute of Technology, he worked with NASA's Jet Propulsion Laboratory as part of the team designing the 8 and 32 GHz transmitter of the Surfsat-1 satellite in 1995. A precursor to the space agency's groundbreaking Cassini satellite project. Later at MIT, Afridi switched to studying power electronics, which operate at much lower frequencies while handling higher power levels. For his new approach to wireless charging roads, Afridi has essentially adapted Nikola Tesla's original wireless power showcase, using a much higher frequency as well as power. The new wireless charging roadway system. For their method, Afridi and his team envision drivers changing lanes to a specially designated charging lane while driving. The team of researchers designed a system that utilizes pairs of insulated metal plates that are placed on the ground. These are connected to a power line through a matching network and a high-frequency inverter. These plates create oscillating electric fields that attract and repel charges in metal plates attached to the underside of the moving vehicles. A high-frequency current is then driven, and rectified, through a circuit on the vehicle, where it charges the vehicle's battery. As electric fields generated by readily accessible voltages are weak, Afridi and his team boosted the voltage for their system and operated it at very high frequencies to achieve higher power transfer. Their system does not require materials such as ferrite and it can operate at much higher frequencies. It is also smaller, lighter, and easier to embed in roadways, making it a more viable option than the magnetic field concept. Working towards global wireless charging road infrastructure. Of course, Afridi and his team's work is very much in the concept stage, and widely adopted wireless charging roadways are by no means a given. Another recent roadway infrastructure proposal, the solar panel road, is a massive engineering failure, for now at least, with several large solar roadway projects failing to meet their stated goals. Afridi claims that the new wireless charging method could be tested on high-traffic roads first or in select roads in cities before being employed at a larger scale. His team is currently working with Toyota Material Handling North America to develop wireless charging for forklifts and material handling mobile robots. If their project delivers on its promise, it could be used to help power the autonomous vehicles of the future around the clock, including self-driving delivery trucks and warehouse machines. The system would also help countries tackle climate change by greatly increasing the efficiency, and therefore uptake, of electric vehicles worldwide.